Okay, everyone, we will now be moving on to 1.5. In 1.4, we did properties of exponents, so we're still dealing with our standard down here, our properties of exponents to rewrite radical expressions, and now we're going to start looking at the radical expressions. So if we take a look at 1.5, which is radicals and rationals, we did our properties of exponents, and we're going to start to look at how exponents have a relationship with radicals. So what I mean by a radical, you guys are typically familiar with square roots, is we have an expression that looks like this, where we have an n root of a, and that's pronounced the nth root of a. You could have a cube root, you could have a fourth root, you could have a fifth root, and the index is the n. So if we're talking about an index, the index could be 3, the index could be 4. So if we have like the square root of 4, that's a radical. If we have the cube root of 8, that's a radical. If we have the fifth root of 5x to the 7th y to the 4th, that's a radical. The index here would actually be a 2 because it's a square root. You can't see it, it's implied. The index here would be the 3, and the index here would be the 5. Now, moving on to the relationship between a radical form and a rational form. And the rational form is where we start to see our exponents pop up, which is what we did in 1.4. So a radical can be rewritten in rational form, and this is where I'm going to tell you a little story. Okay, so inside here we have a k, so my base is going to be k. Now I have a 5 and I have a 6. So that's going to make a fraction over here that's either a 5 over 6 or a 6 over 5. So I'm going to do my fraction. And I have a numerator and denominator. Well, I want you to think of your fraction as a tree. And if you have a tree, you have a top of a tree and a bottom of the tree. And out of the bottom of the tree grows the roots. Okay, so if you're looking at your radical, is this a 6th root or is this a 5th root? And the answer is this is a 6th root. It's a 6th root of k to the 5th. So roots on your trees always go at the bottom of your tree. So the root here, which is your 6, goes at the bottom of your fraction. And then your 5 goes in the numerator. So the rational form here is k to the 5/6 versus the radical form is the 6th root of k to the 5th. Okay, so now let's try to go from rational form over to radical form. So our base is n, so inside the root I'm going to have my n. Then I have a 1/4. So the question is, okay, well if this is my tree, where's my roots? My roots are at the bottom. So my root is a 4. So this is going to be a 4th root, which in this case 4 is your index. Then that means that my power is going to be to the power of 1. So I could either do a power of 1 right there, or your other option is you could put the whole thing in parentheses and do a power of 1 back there, kind of like they did up here. Either one will work, they're both the same thing, but then more importantly here, do you really need a power of 1? And the answer is no, so we're just going to leave it as the 4th root of n. Next one, you're given radical form, we have to write it out as rational form. This time, do you notice that 7v is all inside the root, which means 7v in parentheses all has to be your base. Then you have a 3 and you have a 7. 3 is your index, so 3 is your root, so 3 will go on the denominator, 7 will go in the numerator, so we have 7v to the power of 7/3. Now we're going to go back from rational form to radical form. Do you notice that 4r is all in parentheses? So inside my root, I need all of 4r. Then, because we are dealing with parentheses, I'm going to keep that in parentheses because whatever power I raise it to, I have to raise the whole thing. 5 is my root. 5 goes out as my root. 2 is my numerator. 2 goes back as my power. So that is the fifth root of 4r squared.